Hello and welcome to a very important chapter on Python, which is known as working with functions. So in this chapter, I'll be basically dealing with functions. So it's better you practice alongside me whenever I'll show you the functions or the related codes. Okay, so let's try to understand what a function is. So let's say you are organizing a birthday party for yourself. So for that birthday party, what you are going to do, you have booked a hall. So whoever you have given the contract of managing the hall, they will be responsible for cleaning the hall and keeping it in a proper decorum. Suppose you have given a different company to manage the decoration work. So they will be dealing specifically with the decoration work. Suppose you have given a company the job of managing the food items. So that they will be responsible only for managing the food item. So what will happen in this case is that you will not have to take the headache of managing the entire birthday party. Why? Because you have assigned specific tasks to specific purpose to some specific companies or to some specific organizations. Similarly, in a program also, you may not want to take the entire headache yourself. So what you can do, you can assign some different persons to deal with some specific requirements. For example, let's say you are developing a system for making the software for an ATM. So for making the software for an ATM, there will be various functions like there will be one functions related to withdraw, there will be another function related to money transfer, there may be another function related to deposit. So all these three functions, withdraw, deposit and money transfer, these three functions can be developed by different programmers, and at the end what you can do, you can integrate all of those to make the entire software for the bank. So let's try to understand what a function is technically. So a function may be defined as a group of statements that exist within a program for the purpose of performing a specific task. So the work of function is not to handle the entire thing. The work of a function will be to handle a specific task. So let's go to the types of functions. What are the types of functions? The types of functions are built-in functions, second is modules, and the third is user-defined functions. Let's go to them one by one. So first is your built-in functions. So what are built-in functions? So the predefined functions that are already available in the Python standard library are known as built-in functions. So there are various functions that are already available in the Python standard library. Python standard library means whenever you download Python from the official Python website, you will get certain functions which are already inbuilt into the Python library. Those functions can be used directly, and those are known as your built-in functions. So for using the built-in function, we need not import any module. So let's see some of the examples of built-in function. Some of the examples of built-in functions are, the first is int, float, next is the input functions, next is the eval function, next mean, man, abs, type, length, ln stands for length, range, and there are round and various other inbuilt functions are there. Let's try to understand and implement these functions one by one. Okay, so I'll be implementing here in Anaconda. So this is the interactive mode in Anaconda. So if you are using the basic Python distribution, so if you do it in the interactive mode, you will yield the same result. Okay, so the first type of built-in function is the type conversion functions. So basically the type conversion functions we have in Python are int and float. So what is the use of int? So this function is used to convert floating point number and strings to integers. For example, let's say if I write int 23.76, then you will get the answer as 23. Why? Because 23.76 was a floating point number, but whenever I have used the int function with 23.76, it has been automatically converted to int. For example, let's convert a string. If I write int 764, so why it is a string? Because I have given it within quotes, so it will be converted into the integer form. But if you pass some alphabetic alphabets into the strings, into the int function, then it will give you an error, because alphabets cannot be converted into integers. If you do not pass any argument to int, it will result in 0. Let's go to the next type conversion function, which is float. So similar to int, if we give pass an integer to the float, what it will do? It will convert itself to a floating point number. Similarly, let's pass a string, then also it will convert it into float. So let's try to do a calculation of a string. So if I give float 65 plus 23, so it will yield in 88.0. So these are type conversion functions. That means their main work is to convert from one data type to another. Similarly, here if I want to pass some alphabet to the float function, then it will give me an error. Let's go to the next function. So these are inbuilt function. That means for using this, we need not import any module. So let's say we'll be using the input function now. So let's say, so x equals to input, enter your name, let's say. So then it will come as enter your name. So let me give it as Alice. So it is taking the name. Okay, let's go to the next example. Let's say the next function is eval. So this function is used to evaluate the value of a string. For example, if I write here x equals to eval 2 plus 3. So what should I pass with the eval? I should pass a string. This function is used to evaluate the value of a string. So if I give x now, so it has evaluated the value, that is 2 plus 3 is equals to 5. Let's go to the next function, which is the max function. So if I give, so max function is basically used to find out the maximum value from a list of values. So if I give 9, 8, 55, then it will give me the result as 55. Why? Because 55 is the highest value. So let's say I'll give max like hello, comma, sir. So you should pay attention to one thing here, that H is in capital and S is in small. So whenever I press the enter key, I have got the answer as sir. Why I have got the answer as sir? Because the ASCII value, so S is in small case alphabet, but H is in capital alphabet. So as you know that the ASCII value of smaller case alphabets are greater as compared to greater case to uppercase alphabets, therefore we are getting the result as sir. Let's show you the ASCII value chart. So what is the ASCII value of S? The ASCII value of S is your 115. What is the ASCII value of capital H? The ASCII value of capital H is how much? It is 72. But 115 is greater as compared to 72. Therefore, you are getting the answer as sir. So let's go to the next function, which is the mean function. Similar to max, mean will, what it will do, it will find out the minimum value from the given argument. So what is the minimum among 9, 8 and 55? It is 8. So you are getting the result as 8. Similarly, if I give min, let's say apple, comma, ball. So you are getting the result as apple. Why? Again, let's come to the ASCII chart. So what is the ASCII value for A? It is 65. What is the ASCII value for capital B? It is 66. As the ASCII value for A is smaller as compared to B, therefore we are getting the result as nothing but apple. So while comparing, always the comparison starts from the first character and not the other characters. Let's go to the next type of next inbuilt function, which is ABS. So the main work of ABS function is to find out the absolute value of a particular number. Absolute value means it will always be giving the result in positive, even though we pass it a negative value. Let's say we have passed here minus 78, even then we'll get the answer as 78. Let's try to pass say this one floating point number, let's say 45.1, even then we have, even though we have passed the argument as minus 45.1, we have got the answer as 45.1 itself. The symbol is ignored here. Okay, so whenever I am saying argument, argument means whatever I am passing within the brackets, it is known as the argument. So next thing is the type function. So what is the use of the type inbuilt function? The use of type function is to give the data type of a particular object. So type 10 is an integer, so I am getting the result as int. Similarly, let's try with a string, let's say type high, so we'll give the type as str. Similarly, you can check for floating point number, for boolean, etc. Let's go to the next inbuilt function, which is len. Len is used to find out the length of an object. Let's say if I give len high, so how many characters are there? There are 2 characters, so I am getting the length as 2. Let's say I want to find out the length of a list, so I'll be passing as, let's say 8 3 4 0. So how many objects are there? There are 4 objects, so I'll get the answer as how much? I'll get the answer as 4. Let's try to understand the next function, which is the range function. So range function, if I give range 0, 5, so it will give you the list of values from 0 to 4. So if you want to see the output here, so you have to give list before using the range function. So if I give list range 0, 5, I'll get the answer as 0, 1, 2, 3 and 4. If you directly use the range function in interactive mode, you will not get the list of numbers, but you will get the same result as the input. Okay, so if you want to see the list of values, then you have to use the list function over the range function. Next, let us go to the round function. So round function is used to round off a number. So let's say 45.876. I want to keep 2 digits after the decimal point. So I'll give here comma 2. So the answer is 45.88. Why 88? Because the third character is 6. So as it is greater than 5, so the second character will be incremented by 1. Okay, so this is the first type of function, which is built-in function. So how this built-in function comes? This automatically comes whenever you download the Python from the Python official website. Let's go to the next type of functions, which is the modules. So what is a module? A module may be defined as a file containing functions and variables defined in separate files. So in simpler words, what can we say? We can say that a module in Python, it is a file that contains a collection of related functions. Okay, so let's say you have different books for physics, chemistry, mathematics and all. So in the physics book, you will be getting information only related to physics. In the chemistry book, you will be getting information only related to chemistry, and so on. Similarly, module is a file which contains related functions. For example, we know about a very popular module, which is the math module. Math module is basically used for dealing with mathematical functions. So inside the math module, we will get only the functions related to mathematics. Okay. So in order to use the functions of a particular module, it must be imported before use. So this is a crucial difference between built-in function and module. In case of built-in function, we need not import anything, but in case of modules, we have to import that particular module before using it. So before using the functions of a module, it must be ensured that the modules are installed if it is not a part of the Python standard library. So there are many modules in Python, okay, but only certain module comes along with the Python standard library. So, but if you are using some module which is not a part of Python standard library, you need to download that module, okay, before using it, okay. So, remember this thing, for using the functions of a module, we need to import it at the very beginning. Okay, now let's see how to import these modules. So, for importing the modules, there are basically two ways. So, first way is using the import statement, and the second way is using the from import statement. Let's try to see it one by one. So, first we'll go to the import statement. So, this statement is used to import the entire module. So, if you want to import all the functions of a particular module, you will have to use the import statement. So, when the Python interpreter encounters the import statement, it imports the module if the module is present in the search part. So, if the module is installed in your computer, then you will get all the functions related to that particular module. So, let us see the syntax, how some module can be imported. So, if you want to import only a single module, you need to give the syntax import module name. For example, for importing the math module, you have to give import math. Or if you want to import more than one module at the same time, then you have to use this syntax, which is import module 1, module 2, dot 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 up to module n. So, if you want to import two modules, let's say math and random module, then you have to give the command as import math comma random, and this import statement should be given before using those particular modules. Okay, so let's try to see how these modules are used. So, what is the syntax for using the functions related to a particular module? Number one, you have to import that particular module. Number two, after that you have to use the functions related to the module by using the syntax module name dot function name, and if that function has some arguments, you have to give that argument. For example, for you, after importing math, let's say we want to use the sqrt module. So, what we have to write? We have to write math dot sqrt, and let's say we want to find out the square root of 4. So, we have to give the argument as 4. Let's try to see some of the functions related to math module. So, before using this math module, what we need to do? We need to import it. So, what I will write here? Import math. So, after that, so let's say I want to use the sqrt function. So, what I will give? Math dot sqrt, let's say 4. So, I will get the answer as 2.0. So, there are various functions associated with math module. Let's try to see them one by one. Only some of the functions will be seeing. Let's say I'll be showing you the ceil function. Ceil function is used to find out the next available integer as per the given argument. So, if I give ceil 7.2, what is the next greater integer? It is 8. So, you will get the answer as 8. So, if I give math dot ceil like minus 7.2, what is the next greatest integer? It is minus 7. So, you will get the answer as minus 7. Similarly, there is a function known as floor. Floor means ground. So, you will get the next smallest integer. So, if I give here floor 7.2, so I will get the answer as not 8 but 7 now, because it gives the next smallest integer, not the greatest integer, and so on. There is another function related to math, which is the pow function. Pow function is used to find out the power of a particular number. So, what is the syntax? So, math dot pow, at first we have to give the base. Let's say I will give the base as 2, and let's say I want the power as 3. So, for finding out 2 to the power 3, I have to write it in this particular format. So, I will be getting the answer as 8.0. Next, let's go to the this one. So, here trigonometric functions can also be used. Let's say I will give math dot cos 0. So, I will get the result as 1. Okay. So, for let's say you want to import more than one module. So, you can do it like import math comma random. So more than one modules can also be imported in a single line. So now all the functions related to math module will also be available, and all the functions related to random module will also be available. Let's say random is a different part, so I'll be dealing with it in details in a different topic. So now let's see whether it works or not. Yes. So random function is basically used to generate random numbers from 0 to in the range of 0 to 1. So I've got a random number. So basically what you can see is that both the modules are working together here. Okay, so this is one way of importing the module. Now let's say you do not want all the functions of a particular module. So in that case, you will have to use the second type of import statement, which is from import statement. So this statement is used to import the specific attributes from a module into the current namespace. So let's say you'll be using only sqrt from the math module. So in that case, you need not consume your memory by calling the entire functions of a module. So you can just choose to call only sqrt. So in that case, the syntax will be from module name import the functions name. Let's say you want to have only the two functions sqrt and pow, then you have to write the statement as from math import sqrt comma pow. So how to use it? For using the functions with this particular import statement, you can directly use the function name. I repeat, you can directly use the function name. You need not attach the module name while calling the functions. So directly you can call the functions. For example, sqrt4 will give you the answer as how much? 2. Let's try to use this from import statement. Before that, I'll just clear it and restart the kernel. Okay, so let's say I want only sqrt. So what I'll write? From math import sqrt. Okay, now let's try to use math.sqrt4. It will give me an error. Why? Because I have not directly used the import math statement. I have used from math import sqrt. So if you are using the from statement, then you should not attach the particular module name. So how you can use it? You can directly use it. So if I give sqrt4, I'll get the answer as 2.0. All right. So remember this thing, do not attach the particular module name while you are using the from import statement. Okay. So I hope these parts are clear. In the next part, I'll be dealing with the user defined functions. Okay, thank you very much. And welcome to the chapter working with functions. So this is the part 2 of this particular chapter. In part 1, we have discussed about inbuilt functions and modules. So in part 2, we are going to discuss about user defined functions. If you have not watched the part 1 of this series, you can always check out. The link is given in the description. So here, let us try to understand what user defined functions are. So what are user defined functions? A function that is named and defined by the programmer is called user defined functions. See, many times our requirement is not completely fulfilled by the user defined functions or the functions which are available within the modules. So in those situations, we can make our own functions. So our own function, the functions which are made by the programmers, those are known as user defined functions. Let's consider a scenario. Let's say you are being given with the job of making a software for an ATM. So in ATM, there can be various functions. Let's say one function is deposit. Let's say one function will be withdraw. Under that, all the things related to withdrawal will be there. Let's say there is another function which is your fund transfer. So let's say everything related to fund transfer will be here. So if you do not use the concept of functions, then let's say the sequence is at first deposit will be made, then withdrawal, and then fund transfer. Till the work of the function, till the work of deposit is not completed, the work of withdraw cannot start. Until the work of withdraw is not completed, the work of fund transfer cannot start if we do not use functions. But if we use functions, if there are 3 members in a group, all the 3 members can be assigned separate tasks, like one will be dealing with deposit, one will be dealing with withdrawal, and other can deal with fund transfer, and they can develop their part parallelly, and after developing it parallelly, at the end it can be merged. So what will happen in this case? The time taken for the project completion will be reduced drastically. Also, you should note one thing, that these functions like deposit, withdraw and fund transfer, these are customized functions. Therefore, these will not be present in the Python library. So you need to make these functions by yourself. So if you are making some functions by yourself, then it is known as user defined functions. What are the advantages? First is parallel programming. Second can be the time is reduced drastically. Okay, I hope it is clear. Now let us go and see the syntax of user defined functions. So for writing a user defined functions, it begins with the word DEF. DEF stands for function definition. After DEF, I will be writing the function name. So in our previous example, let's say we will be dealing with the deposit function. So we'll write DEF deposit. Then within the first bracket, if there are some arguments, so those will be written within these braces. After that, we need to end this line with a colon. After that, what we need to do, we need to write the statements which will be a part of function header or function definition. So there can be various statements within the function definition. So statement 1, statement 2, dot 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 up to statement n. And at the end, suppose these are certain calculations. After doing the calculations, what we can do, we can return the answer to the function, to the main part. It will be more clear when we complete this entire session. So make sure you watch till the end. So this particular part from statement 1 to return variable name, this is known as the function body. What is the work of function body? Function body prescribes how a particular function work. For example, if you are writing the function for deposit, within the function body of the function deposit, you will be writing the logic in which the function deposit will be working. And this return variable name means at the end you can take a variable which will return the ultimate result of that particular function. So this is the syntax for function definition. After doing the function definition, let's take an example. Let's say we'll create a function called calsum. So we'll write def space calsum, then within bracket this p and q, these are known as your parameters, or it may be said as arguments also, but specifically parameter is the correct word. So after giving the parameters, in the next line we'll be writing the list of statements. So here we have written s equals to p plus q and then return s. Return s means after adding p and q, the result is stored in s and then s is returned to the main function. Okay, this is the first part of user defined function. What is the second part? So this is called as the function body, and next part is the function calling. After we define a function, for it to be used properly, what we should do, we should call the function. Okay, so using a function that has been defined earlier, it is known as function calling. So recently we discussed about the function calsum. So for using the function calsum, we need to call it. So what is the syntax for it? The syntax is we'll write the function name and then the arguments needs to be written. If the function definition contains argument, then in the function calling also there will be some arguments. So for example, how to use the function calsum? So we'll write calsum, then here we can, so there were 2 arguments or 2 parameters in the function definition. So in the function calling also there are 2 arguments. Okay, so the last line is very important. Here the arguments are optional. If the function definition contains argument, then the function calling must also include arguments. So in our previous case, the function definition calsum, it contained two arguments or two parameters p and q. So in the function calling also we'll be having two arguments x and y. X, y, p, q, these are nothing but just normal variables. Now we need to be very clear about two terms, parameters and arguments. So what are parameters? The values that are passed in the function header are referred to as parameters. So what is function header? The whatever we write after def, it is the first line of function definition, it is known as the function header. So under function header, if within bracket, if we write certain variable names or some numbers, those are known as parameters. The parameters are also known as formal parameters. For example, here you see df calsum p comma q. Here p and q are referred to as your parameters. Okay, so the values which are passed in the function header. What is the function header? The first line of function definition is known as function header. So whatever value we pass here, they are known as parameters or formal parameters. So p and q, they are referred to as parameters. Okay, let's go to the next term, that is arguments. So what are arguments? The values that are passed in the function call statement are referred to as arguments. So which is these arguments, these are also known as actual parameters. So for example, in our previous slide, there we used the function calling calsum x comma y. This x comma y, these are known as your arguments or actual parameters. Okay, these two values will go and it will be matched with the function definition header. It will be more clear when we go to the programming part. So let us see a program with functions. So for writing a program with function, we require two things. One is the function definition, next is the function calling. So at the very beginning, what we will write? We will write our list of functions one by one. It's not that in a program only one function can be there. There can be more than one functions in a program. Okay, so after writing the list of functions, what we will do? We will write the main program. What is main program? Till now, whatever programs you have written in class 11, all those are a part of the main program. But here we will not write the main program directly. At first we will be writing the function definitions. After writing the function definitions, we will be writing the main programs. Let us write a complete program now in relation to functions. I'll just show it in the slide first, then we'll go to the programming part. So at first, what is written? The function definition part is written. So this is what? This is function definition. After that, the actual programming part or the main program is written. So the second part, from x equals to int, input enter first number, it is called as the main program or the top level statements. You can just match it with the this one syntax. So these are known as your function definitions and these are known as your top level statements or the main statements. Okay, also you should keep one thing in mind, that def and this x or the main program should come at the same indentation level, and the statements within the function definition should be at a different indentation level. So this part is known as what? Let's revise it again. It is known as function definition, and this part, it is known as the top level statements. Okay, I hope this part is clear. Now let us go to the programming part. So let's develop a small Python program to add two numbers. So for adding two numbers, what we will do? At first, what is to be written? We should write this one, function definition. So function definition starts with def. So we'll write def. Then let's say we'll write this one function name. Let's say the function name is calsum. You can give any function name as per your choice. There's no fixed rule with that. So then we'll pass this parameters. Okay, so after that, what we can write? We can write the logic. So let's say we'll write s equals to p plus q. Okay, after that, let's write the return statement. So after doing the calculation, we'll be returning this value to the main function. Okay, we'll write return s. Now we need to break the indentation. Why? Because see, the main function should start at the same indentation level with the DEF. Okay. So here we'll write the main statements. Let's say, what is it? X, let's say x equals to int input. I'll write in short, let's say enter the first number. Okay, then let's say we'll take a variable y and write here int input. So this is the script mode in Python. You can use any editor for that. Enter the second number. Okay, and then what we'll do, we'll take a variable for storing the result. So if there is a return statement in the function definition, then you should store the result in some variable before calling the function. Now what is the name of our function? The name of our function is calsum. So what we'll do, we need to call the function. So calsum. Okay, so here where did we receive our numbers? We received our numbers in x and y. So we'll write calsum x comma y. So finally what we'll do, how it works, so I'll be explaining it to you in details. So print, so we can write result is, so the result will be stored in sum. So result is your comma sum. Okay, so this is the entire program. Now how does this program run? I'll explain it to you. So let's run and see it. So enter the first number. Let's say the first number is 4. Enter the second number. Let's say the second number is 8. So the answer will be, so the result is how much? The result is your 12. Okay, so this is the program of addition of two numbers with the help of a function. Now let us see how does it runs, or how does a function actually works. So for the working of a function, so this was our program. So this was our program here. See, at first which line will run? This particular line will be executed. Okay, so this is known as code tracing. So at first line number 1 will be executed. After that, as it encounters the DEF statement, the control will be transferred to the main program. So which line contains the main program? The fourth line. So after 1, which line will be executed? The line number 4. After that, which line will be executed? The line number 5 will be executed. After that, which line will be executed? The line number 6 is executed. If you pay attention, in the line number 6, what we have done here, we have done the function calling. So whenever function calling is encountered, the control gets back to the function definition. So from here, from line number 6, it will not go to line number 7 directly. So the program will pause at this particular point at line number 6. After pausing at this particular point, the control will be transferred to line number 1. So in place of x, let's say you have given 2. In place of y, let's say you have given 5. So x will carry the value 2 and y will carry the value of 5. Now this 2, that is the value of x, will be copied to p. So what will be the value of p? The value of p will be 2. What will be the value of q? Q will be the equivalent value of y, that is 5. So p is 2, q is 5. So s equals to p plus q means here what will be done? 5 plus 2, that is 7, and 7 will be stored in the variable s. Now what is stored in the variable s? 7 is stored in the variable s. Now that s, see, next line is return s. That 7, that particular 7 will be returned to which line? It will be returned to line number 6. Okay, now that 7 will be stored in the variable sum. Okay, so final answer is stored in which line? It is stored in line number 6, and in the variable, which variable? In the variable sum. After that, which line will be executed? The line number 7 will be executed, and our answer will be displayed as sum is, what is the sum? The sum is 7. So how do we trace this program? We will trace this program in the following manner. So at first, line number, so let me erase the complete thing. Okay, so at first line number 1 will be executed. As it encounters DEF, it will go to line number 4, then 5, then 6. From 6, it will go again to line number 1. From line number 1, it will go to which line? It will go to line number 2. Then it will go to line number 3. After 3, it will go to that particular line which has called it. Which line has called it? The line number 6 has called it. So it will go to which line number? It will go to line number 6. After 6, it will go to which particular line number? It is known as, it will go to line number 7. So this is the flow of execution of this particular function, and it is also known as code tracing. In exam, this question is important. A code will be given, and after that you will be given to trace that program, and you need to trace the program in this particular manner. Hope you have got understood the basics of user defined function. More about it in the next part. Okay. Hello and welcome to the third part of the chapter on working with functions. I hope you have watched the previous parts of the series. If not, you can always go and check them out. The links are given in the description. So in this part, we are going to talk about returning values from functions. So let's begin with today's session. So returning values from functions. So functions, they may return a value or may not return a value. When there is a return statement in the function definition, we say that function returns a value. If there is no return type on the function definition, then we say that functions is not returning any value. So based on it, there are two types of functions. First is non-void function and second is the void functions. So let's begin with the non-void functions. So what are non-void functions? The functions that return some value are known as non-void functions. That means these are the functions which have a return type. So if you are working with non-void functions, then in the function definition, always a return type should be there. So these functions are also known as fruitful functions. So non-void functions also has a different name. It is also known as a fruitful function. So let's see the syntax of non-void function. In case of non-void function, what you need to do, you need to write return. After that, you can return a value like 2, 3, 4, 5, etc. You can return a variable like x, y, z, or you can return an expression like x plus y, x into y, and so on. So let's try to understand about non-void functions with the help of an example. So the previous example that we saw is this particular example. What we did, we learned how to add two numbers using the concept of function. So if I run this particular, if I run it, so what you will get here, you will get enter the first number. So let's say the first number is 4. Enter the second number, let's say the second number is 5. So you are getting the sum as 9. So in this particular program, what we are doing, what we are returning a variable. So return as denotes we are returning a variable. Instead of a variable, we can return a value also, or we can return an expression also. Let's show you how to return an expression. So let's say you want to return the expression directly, like you want to return p plus q directly. Then what you will do, you will not write this line, and instead what you can do here, you can return the expression p plus q directly. Will the program work properly now? So let's see. So enter the first number, let's say 7, enter the second number, let's say 3. So we are getting the correct answer. So remember, you can return either a variable or an expression or even a value also. Let's try to see how to return a value. So pay attention to this particular program. So here we have defined a function tt, and here inside the function definition, inside the function body, we have just one statement, that is return 3. So here what we are doing, we are returning a value. So how it will run? At first line number 1 will be executed. So if I trace it, how it will be traced? At first line number 1 will be executed, then line number 3 will be executed, then line number 4 will be executed. After that again line number 1 will be executed, then line number 2 will be executed, then line number 4 will again be executed, and then line number 5. So what will be the output of this program? The output of this particular program will be hello 3. Okay, why? Because at first the line number 1 is executed, after that line number 3 is executed. In line number 3 what is there? Hello. So we are getting the first line of output as hello. After that here tt function has been called. This is known as your function calling. The tt function has been called. After that what is it returning? It is returning the value 3. After that 3 is being stored in the variable x. So finally x has been printed. So we are getting the result as how much? We are getting the result as 3. So we can return 3 things: a variable, an expression, or a value. So in this particular program what we have returned? We have returned a value. Okay, so let's go to the next topic, which is there are some properties of non-void functions. So let's go and see these properties. What is the first property? The first property is that the return value of a function must be used in any of the following ways. So after returning a particular value, from where is a value returned? A value is returned from the function definition. After returning a value, the value can be used in the following ways. What are the ways? The first way is this particular way. This is the way in which we used in our previous session. What we did the function calling, and after that the returned result has been stored in a variable add. Okay, the next way of storing the return value is this. We can directly call it within print statement, or we can even compare it. Let's try to show it to you with the help of an example. Okay, so let's consider the first program of addition of two numbers. Here what we were doing, so this is the line, this is the property number 1 of non-void functions. So here what we have done, whatever is the result of p plus q, it has been stored in the variable sum. After that we have displayed the variable sum. Instead of this we can use the second syntax also, which is we can directly use this particular function calling in the last statement. Let's delete it. So what we can do here we can do the function calling c sum. We can directly use what are the variables that will be sent here. The variables will be x and y. So if I run this program, see, first number is 9, second number is 1. So I'm getting the correct answer as 10 itself. Okay, so this is the second way in which you can do function calling. Okay, instead of using another step of storing it in a different variable, you can directly use the function calling in a print statement. Let's see the third way. What is the third way? In the third way, we can compare. In function calling itself, we can compare the values. For example, what we can do here, if I give a statement like if c sum x comma y greater than 20. So what we can do, we can just write a statement, let's say greater. So we can give an else statement also, else print. Let's say we can give another statement called smaller. Okay, so let's see how it runs now. The other parts are same. let's say we are giving here 9 and 1, so the sum is 10. So here the comparison has been done. I think you have understood till this part, so I'm going to explain this. So if C sum xy, that means if the return value of this particular function is greater than 20, then what will be printed? Greater. Otherwise, what will be printed? Smaller. So according to our inputs, we have inputted what? 9 and 1. So what is the sum? The sum is 10, which is less than 20. So we are getting the output as what? We are getting the output as smaller. Similarly, let's give a greater value. Let's say 9 and 22. So the sum is 31. So after comparison, we are getting the output as greater. Okay. So these are the ways in which you can call a function. You can either call and store it in a variable. You can either, or what you can do, you can directly use it in the print statement, or you can use it as a part of the relational expression also. Let's go to the second property of non-void function. What is the second property? The return statement ends a function execution even if it is in the middle of a function. So it's not mandatory that the return statement should be at the end of the function definition. You can put the return statement at the middle of the function definition also. Let's go and see it with the help of an example. So let's say you were absent today in the class, and then when you come to the school in the next day, your teacher may ask why you were absent yesterday. You may say that you were sick, but actually what the reason of your absent was that you went to your cousin's wedding. So keeping this thing in mind, I have developed a program. So see, what is the name of the function? The name of the function is test. After that, what are the lines within the function definition? First is print I was sick. After that, we have given a return statement. After that, I have given print I went to my cousin's wedding. Let's say this is the thing which is in your mind. This is the real reason, and let's say this is the spoken reason. So how will this program run? So the program will run as follows. As at first, what will come? See, the first line will be executed. After that, the fifth line will be executed, which is why you are getting the first line of output as why were you absent yesterday. After that, there is a function calling. So the control has been transferred to line number 1 again. After that, what has been printed? I was sick. So you are getting in the output I was sick. After that, what we have? We have a return statement. Therefore, forcefully the function has been terminated and it has been returned. So we are getting the output as I was sick, but we did not get the output as I went to my cousin's wedding. Why we didn't get it? Because before this particular statement only we have used the return statement. Okay, so whenever a return statement is encountered, at that time what will happen? The value or whatever you are returning, it will come to the function calling itself. Okay, and you can leave, you may not return any value or variable or expression also. If you just write the return statement, then also the function definition will be terminated and control will return back to the function, return back to the main program. I hope you remember about main program. This is the main program and this part is the function definition. Okay, so which is the second property? The return statement ends a function execution even if it is in the middle of a function. Okay, that's all about non-void function. Let's go to the next one, which is the void function. Void function means the function that performs some action or do some work but do not return any computed or final value to the caller are called non-void function. So it is not necessary that function should have a return type. Functions may not have a return type also. So those functions which do not have any return type are known as void functions. Okay, so let's try to implement void function. Also, the second point is that functions that do not return any value are known as non-fruitful function. So functions which do not return any value, they are known as non-fruitful functions. Okay, let's try to implement non-fruitful function or functions which do not have any return type. So let's try to implement this part only. So what we'll do here, I'll remove some lines. Let's say these lines are not required. So here let's say this line is also not required. So what we'll do here, what is the name of the function? Let's call the function name is csum. So let's write here csum xy. So whatever value we'll be giving in x and y, it will be copied to p and q respectively, and after that the calculations will be performed based on it. So we are discussing about void functions, so no return type is required. So what we can do here is that, so you can just give here z equals to p plus q, and we can write here the result is, let's say, where is the result stored? The result is stored in z, so we can write here z. So is the function returning any value? No. Therefore this function is known as a what function? Void function. So let's run and see it. So enter the first number 9 and 1, so I'm getting the result as 10. So if you choose not to return a value, then the final computed result should be displayed within the function definition itself. Okay. Next, returning multiple values. So you may choose to return more than one values also. Okay, it's not mandatory that you have to return only one value or only one variable. You can return as much variables or expressions as you want. So if more than one value is returned, then it can be stored either in a single variable, which is stored as a tuple, or in more than one variables. Now how will be the return result stored if you are using multiple return values? So the returned result can be stored in a single variable also. If it is stored in a single variable, it will be stored in the form of a tuple. But if it is stored in multiple variables, then the variables can be displayed individually. It will be clear when we go to the programming part. So what is the syntax for returning multiple values? So we'll write the return statement. After that, value, variable or expression, whatever you want, you can just write the value or variables or expression by separating it with a comma. Here val indicates the value, var indicates variable, and exp indicates here what? It indicates your expression. So let's try to understand the concept of returning multiple values. So here there are two cases. We can store the result in a single variable, or we can store the result in multiple variables. Let's at first begin with storing the result in multiple variables. So this is a program. So write a program in Python to illustrate the concept of multiple return types using different variables for storage and display. Okay, so some parts will be common. So let me copy it from here so that we do not waste time here. So this parts will be common. So let's define a function. Let's say the function name is clc. Let's say the variable names are xy. Okay, then we can choose to return. Let's say here we'll be performing addition, subtraction and multiplication together. So here what we can do, return x plus y, x minus y, we can do x into y. Okay, after that, so now we'll be storing the results in different variables. Let's say we'll give one variable add. Here we'll be storing the result of x plus y. Then let's say I'm giving a variable sub for storing the result of x minus y, and then let's say I'll be using a variable prod for storing the result of x into y. So equals to, let's say I'll be giving here calc x comma y. Here you may have used pq also or any other variable also, it does not matter. Okay, so after that what we can do, print, let's say sum. So addition is stored here, so print, let's say difference say will be displayed in sub. Let's say next is product, and so the product is stored in the variable prod, so we'll be displaying the variable prod. So let's run and see. After that I'll be explaining it to you. So the output is enter the first number, let's say I'll be entering 6, enter the second number, let's say I'll be entering 2. So the sum is 8, difference is 4, the product is 12. So here what we are doing, we are using multiple return type. We are returning multiple values or multiple expressions here, x plus y, comma x minus y, comma x into y. So how does the program run? At first line number 4 will be executed because 1, 2, 3 are comments. After that line number 6 will be executed, then line number 7. Then in line number 8, the function calling is happening here. So CALC x comma y. So what are the values? 6 and 2. So 6 and 2 will go and it will be copied to the variables x and y here itself. After that x plus y, that is 6 plus 2 is 8. 8 will be returned and stored in the variable add. X minus y, that means 6 minus 2, 4 will be returned and it will be stored in the variable sub, and similarly for product also. After that what we have done, we have displayed the variables. Okay, so this is a program in which we are using different variables for storage and display. So now what we can do, we can use only a single variable also for storage and display. Let's try to understand how to use a single variables for storage and display. For that, let me copy this part. So see the name of the program, write a program in Python to illustrate the concept of multiple return types using single variable for storage and display. Here we are using 3 variables for storage and display, but in this program we'll be using only 1 variable for storage and display. As per the theory, it will be stored in the form of a tuple. Okay, let's try to implement it. So I'll be using the same function calc and I'll be using the same operations. These 2 lines will be the same. Just what will be changed here, I'll be using only 1 variable. Let's say the variable is z, and what I can do here, I can just print out operations in sequence. Let's say at first we'll be displaying at first which result will be displayed, the result of addition, it will be in the sequence only. Then the difference result will be displayed. After that, which result will be displayed, the product will be displayed here. Okay, so it is stored in which variable? It is stored in the variable z. Okay, let's save it. Okay, and let's run it. So enter the first number. I'll give the previous sets of input only. Let's say I'll be giving 6 and 2. So you are getting the answer as operations in sequence, addition, difference, product. Addition is 8, difference is 4, and the product is 12. So here it is the same as the previous problem, just with the difference that I am using only a single variable for storage. This is the using the single variable for used for what? Storage. Here I am using z for what? Here I am using z for display. Okay, so I hope this session was useful. I'll see you again in the hello and class. Welcome to the chapter working with functions. So this is the part 4 of this particular chapter. If you haven't watched the other parts of this chapter, then you can always go and check out. I've given the link in the description. Okay, so today we are going to discuss about tracing programs. We'll learn how to trace programs line by line. So before that, we need to know the rules for tracing the functions. So what are the rules? There are just 2 rules, and just by using these 2 rules, you can trace any function. So what the first rule says? The first rule says that if a function definition contains a return type, the control is transferred to the line where function calling occurred. So if you have seen the other parts, there in some functions there was something at the end called as the return statement. So if a function definition contains a return type, then the control will be transferred to the line where function calling has occurred. It will be clear when I go to the problems. So the second rule says that if a function definition does not contain any return type, so it's not mandatory that a function has to contain a return type. It may contain a return type or it may not contain a return type. If a function definition does not contain any return type, then the control is transferred not to the function calling line but to the next line after the function call. Let's see what these rules mean. So for that we will see the first question. So trace the following programs. That means you'll be given some lines of code. Along with that, these are the line numbers 1 2 3 4 5 6 and this is the code. Okay, so we have to trace this program. So let's go and learn how to trace this particular program. So this is the program which we had. So here, which line will run first? The line number 1. Okay, so at first the first line will be running. After that, this is the function body of the function definition, so this line will be skipped. So next, which line will run? The third line will run. Okay, next, which line will run? The fourth line. Next, which line will run? The fifth line. See, this is function calling. How do we know that this is function calling? Because what is the name of the function? The name of the function is increment. So wherever we are getting the word increment, that means that is a function calling. So whenever function calling encounters, at that time the program will pause and the control will transfer to the function definition. That means after fifth line, the control will go to the first line again. After that, which line will be executed? The second line will be executed. Now you need to revisit the rules. What does the rule says? No return type, then next line after the function calling. So if there is no return type, then the control will be transferred to the next line after the function calling. Okay, so here do we have a return type? No, here we do not have any return type because return statement is not there. So after the second line, the control will not go to the fifth line. It will go to which line? The line after the function calling. So this is the function calling. Which is the line after the function calling? The line after the function calling is the sixth line. So after the second line, so the control will be going to the sixth line. So this is the complete tracing of this particular program. So now if they ask you to find out the output, how to find out the output? Just go by the tracing, first line, third line. So x is 3. So x will carry the value of 3. Then print x. So let's say this is the output screen. So what is stored at x? 3 is stored at x. So 3 will be displayed in the output screen. After that, we have the increment x. So 3 will be carried in x and this 3 will be copied to this variable x. So here in the, now after the first line, the second line will be executed, x equals to x plus 1. So x equals to x plus 1 means 3 plus 1 is how much? 4. So after, so now x has the value of 4. But is there any return type? No, there is no return type. Therefore, the value 4 will not be returned to the calling function. So after the second line, the control will go to the sixth line. But there is no return statement here. So we will not get the answer as 4. We will get the answer as 3 itself. Okay, why this is so? Because there is no return type and there is a difference between this x and this x. Their names are same but their memory addresses are different. Therefore, as we do not have any return type, we are getting the earlier value only, which is the value 3. Let's run this program and see. So this is the tracing and this is the output. So let's run this program and see. So this is our code. So if we run, you will get the output as 3 and 3. So let's go to the next one. So if you are asked to trace this program, so you will write the in this form. This is the tracing part, as I have shown you the explanation how to do the tracing. And next, if they ask you the output, you have to write the output in this form. Let's go to the next question. Trace the following programs. So this is the next question. Let's learn how to trace it. So this is the next one. So here, see at first which line will run? The first line, after that the second line, after that the third line. No, sorry, I made a mistake here. At first the first line will be executed. After that, this is the function body. The function body will be skipped. So which line will be executed? The fourth line will be executed. After that, the fifth line will be executed. After that, the sixth line will be executed. At the sixth line, what is happening? Function calling is happening. So the control will go to the first line. The program will pause at this point, the main program, and the control will go to the function definition. That means after sixth line, which line will be executed? The first line will be executed. After that, the statements inside the function body will be executed, which is line number 2. After that, which line? The line number 3. Here what we have? Here we have the return statement. What the rule says, I'll just repeat it again. So if there is a return type, then the control will go to the line of function calling. That means whatever line has called the function, the control will go to that particular line itself. Okay, so let's proceed with the calculations. So here, after the third line, it will not go to the seventh line. It will go to that line which has called it. So which line has called it? The sixth line has called it. So after the line number 3, the control will go to line number 6. After that, it will go to line number 7. Okay, I hope it is clear. So no return type, then it will go to the line after the function calling. If there is a return type, then it will go to that line which has called it. So this is the tracing of this particular function. Now, if they ask you to find out the output, let's find out the output. So here x has the value of 3. So print x. So if this is the output screen, what will be printed first? X will be printed. After that, y equals to increment x. So x will take the value of 3 and it will copy the value of 3 to this particular statement. Okay, after that, here what we have, x equals to x plus 1. So 3 plus 1 is how much? It is 4. After that, here what we have, here we have the return statement. So this 4 will not stay here. It will be carried to the line which has called it. So it will be carried to line number 6. So this 4 will be stored in the variable y. After that, it will go to the 7th line. What is displayed here? Print y. So what is stored in y? 4 is stored in y. So the output will be 3 and 4. Let's run and see the output here. So this is our program. So if we run it, I will get the answer as 3 and 4. So this is how you find out the output and the tracing. So if you were asked with the tracing of this particular program, you will write the tracing in this form, and if you are asked to find out the output also, you will write the output in the following form. Let's go to the last question of this particular part. So here we have this code and we need to trace this code. Here we have, see, more than one functions. Here we have 2 functions and 9 lines. So let's learn how to trace this particular question. So this is our question. So at first, which line will be executed? The line number 1 will be executed. After line number 1, it will go to the next function definition, which is line number 4. After this, it will go to the main program, which is line number 7. After that, it will go to line number 8. See here function calling is happening. So at first, cal square function will be called. So from here, it will go to line number, how much? It will go to line number 4. Okay, so after line number 4, it will go to line number 5. So at line number 5, again function calling is occurring. So from line number 5, the control will again jump to line number, how much? Line number 1. Which function has been called? The power function has been called. So the control will again jump to line number 1. After that, it will jump to line number, it will execute the statements within the power function, so which is line number 2. After that, it will go to line number, how much? 3. Here return statement is there, so the control will go back to line number, how much? Line number 5. So after line number 5, it will go to which line? It will go to the next line, which is line number 6. Here do we have a return statement? Yes, we do have a return statement. So as we have a return statement from line number 6, it will go to line number 8 because this is the line which has called it. So after 6, it will go to line number 8. After going to line number 8, here see another function calling is happening, which is the power function. So here after line number 8, the control will go to line number 1. After going to line number 1, it will go to line number 2, then line number how much? 3. Again return statement. So the control will come to line number how much? 8. So after line number 8, it will go to line number how much? It will go to line number 9. So this is the complete tracing of this particular program. Okay. So there can be multiple function definitions here. Okay, now let's go and find out the output. Before that, please wait for some time. I'll just clear the screen. So there can be multiple function definitions and there can be multiple function calling also, and more than one function calling can also happen in a single line. Okay, now let's go and find out the output of this particular program. So at first line number 1, then line number 4, then line number how much? 7. So in line number 7 we have n equals to how much? 5. So then line number 8, cal square n. So the value of n is 5, so n will be copied to this particular line. So x also has the value of how much? 5. So then we go to line number 5, a equals to power x comma 2. So what is the value of x? The value of x is 5. So 5 will be copied to b and this 2 will be copied to p. So now b is how much? B is your x, which is 5, and p is how much? P is your how much? 2. So now what we have? Y equals to b into p. So what is the meaning of this? This is the exponent. So this is the exponential form. So here what we will find? B to the power p. The meaning of this line is b to the power p. So the value of b is how much? 5, and the value of p is 2. So 5 square is how much? 25. So 25 will be returned to this line, the 5th line. After that it will go to the 6th line, and after that it will go to the 8th line. So what is the final result of the first part of the 8th line? The final result is how much? 25 plus. But we have another function calling here, which is the power function. So this 3 will be copied to b and the second 3 will be copied to p. So here what we have? Y equals to b into p. That means it is 3 to the power 3. 3 cube is how much? 3 cube is your 27. So then we go to line number 3. From line number 3, the control will return to the line number 8, which is the second part of line number 8. So now finally we have the, what do we have in the variable result? We have 25 plus 27. Now just solve this. 7 plus 5 is 12. 2 carry 1, 2 plus 2 4 plus 1 5. So the final result stored in the variable result is 52. After 8th line it will go to the 9th line. So what will be the output? Our output will be your 52. Let's go and run this particular program. So if I go to run this program, so this is our program. Here we have how many lines? 9 line. Here I have given a space bar, so it is showing the 10th line also, but there actually here we have 9 lines. So if we run it, we'll get the answer as nothing but 52. Okay, I hope tracing programs is clear. So if you have to write it, this is our tracing part, and then if you are asked to find out the output also, then below you will write the output in the following form. Okay, so that's all about the tracing of programs related to functions. I hope that this session was useful. I'll see you again. Thank you very much. Hello and welcome to the chapter working with functions. So this is the part 5 of this particular chapter. I hope you have watched the previous parts of this series. If not, then you can always check out. I have given the link in the description. So today's topic of discussion is scope of a variable. So let's go and understand what do we mean by a scope. Before going to the technical definition of scope, let us try to understand it with the help of a real life example. So let's say you have gone to an amusement park. Let's say the name of that amusement park is ABC Park. Let's say there are 3 sections in the amusement park. So let's say the first section is game section, let's say the second section is toy section, and the third section is your 3D movie section. Let's say the management of this park issues 2 types of tickets. One is the basic ticket. The basic ticket will allow you to games and toys, and other is the premium ticket. So if you purchase the premium ticket, then you will be allowed to games, toys and movie. So if you, let's say you purchase the basic ticket, then you will be allowed entry in the games and you will be allowed entry in the toy section, but you cannot go in the 3D movie section. Let's say you purchase the premium ticket, then you are allowed entry in the game section, in the toy section and also in the 3D movie section. That is, you are allowed entry in the entire section, in the entire park. Okay, so what is making the difference whether you can enter in games and toys section or in all the section? This particular ticket is making the difference. The basic ticket has validity only in these 2 and the premium ticket has validity all around the park. Okay, so now let's try and understand what do we mean by a scope. So what is a scope? Is the scope of a variable refers to the part of a program within which a name is legal and accessible. So in a program there are various parts. So within what part a particular variable is valid, it is known as the scope. There are 2 types of scope basically. First is the global scope and the second is the local scope. Let's try to understand what do we mean by global and local scope respectively. From the name only it is evident that local scope will have a wider acceptance and global scope will have a wider acceptance and local scope will have a little bit less acceptance. So let's try to understand the meaning of global scope. So what is global scope? So a name declared in the top level segment of a program is said to have a global scope and is usable inside the whole program and all the blocks contained within the program. So in a program related to functions, there are basically the functions and the main program. So whatever variables names we declare within the main function, it comes under global scope. Okay, so what is a global variable? A variable declared in the main program is called a global variable. So whatever variables we will declare in the main part of the program, that is known as a global variable. So the global variables have global scope. What is the meaning of this particular sentence? Global variables have global scope means whatever we will declare in the main program, it is accessible throughout the entire program without any restrictions. Variables declared outside all functions are global variables. Also, whatever variables we will declare outside all the other functions, that is also known as a global variable. So let us try to understand it with the help of an example. So let's take an example. Let's say this is an example related to global variables. So here, as you can see, here we have 12 lines in this particular program. Now in this program, what will classify as a global variable? At first, let me remind you that this is called as the main program. So as per the definition, what are the variables declared in the main program? Z and X. So Z and X has a validity throughout the entire program. It can be used in all the lines from 1 to 12. So this 7th and 8th line has a global scope. Also, we got another sentence that the variables which are declared outside all the functions also have a global scope. By that, going by that definition, the line number 1 will also have a global scope. Okay, I hope this is clear. So now let us try to find out the output. So what will be the output? So remember now, Z, X and P can be used throughout the entire program. So at first, which line will run? So at first P will be initialized to 4. After, so this line, after the DEF is there, so it will come, jump to the 7th line. So after that, what will come? It will jump to the 8th line. So P is initialized as 4, Z as 8 and X as 3. After that, increment X. So the 3 will be copied to here. Now Y also has the value of how much? 3. So here what has been done? Y equals to Y plus 1, that is 3 plus 1 is how much? 4. So now Y has the value of 4. After that, let's say this is our output screen. What will be shown there? Print Y equals to Y. So the first line of the output will be Y equals to how much? Y equals to 4. What will be the second line of the output? Z inside the function, comma Z. So Z is a global variable, so it is accessible throughout the entire program. So what will be the value of Z that will be displayed? So it will be displayed that Z inside the function. After that, what is the value of Z? The value of Z is 8, so 8 will be displayed. After that, what is the next line? P inside function. So P inside function, what will be displayed here? P, what is the value of P? The value of P is how much? Nothing but 4. So 4 will be displayed. After that, the entire function definition is complete. So the control will come back to the 10th line now. In the 10th line, what is given? X inside main program, comma X. So what will be displayed? X inside main program, comma X. What is the value of X? The value of X is how much? It is 3. After that, which line will come? This particular line, Z inside main program, comma Z. So what is the value of Z? 8. So after that, what will come? P inside main program, comma P. So P inside main program. See, this P is also a global variable, so it is also accessible throughout the entire program. So it will show the value as how much? It will show the value as 4. Understood the output? So the final output, let me run this program and show it to you. So this was our program. This is the program. So if I run it, you will get the answer as this: Y equals to 4, Z inside function 8, P inside function 4, X inside main program 3, Z inside main program 8, P inside main program 4. So the basic thing to take away from this particular program is that if we declare a variable as a global variable, then it will be accessible throughout the entire program. It will be accessible. What is the meaning of this word? Accessible. It will be accessible means you can use that particular variable throughout the entire program. You can use it in the main program also. You can use it in the main program also. You can use it in the function definition also. Also, you can use it outside all the functions also. Okay, I hope the global scope is clear. Now let me just show it to you. So this was our program. So here, if we revise it, here P is a global variable because it is accessible throughout the entire program. Also, Z and X is also known as a global variable. So these three because these three variables can be used outside throughout the entire program. Now this will be the output of the program, as I have already explained the output. So this is known as the output of the program. So next, let us go to local scope. So a name declared in the function body is said to have a local scope. So whatever variable names we will declare within the function body, not in the main program, only within the function body is said to have a local scope. It can be used only within the function in which it is declared and the other blocks contained under it. So if we declare a variable within a function body, then that variable can be used only within that particular function, not outside the function. I'll explain with the help of an example, then it will be more clear. So what is a local variable? A variable defined within a function is called a local variable. Local variables have local scope. Why? Because it can be used only locally within the program. Therefore, it can be said that it has a local scope. So let's try to understand local scope with the help of an example. So here let's consider this program. So here this part from line number 3 to 6, this is called as within the function or function body. From line number 7 to 13, it is known as the main program. Okay, so from that, can you say which are the local variables? Yes, this y, the line number 3, whatever we are having, or here also whatever we are having, it is known as the local variable, and local variable has a local scope. That means we can use that variable only within that function, not outside that function. Okay, so here we have done one mistake. What is the mistake that we do? We have used the variable y in the main program also. See the last line, print y inside main program comma y. Okay, but it is not acceptable. Why it is not acceptable? Because the variable y has a local scope, so it can be used only within this particular part. That means from line 3 to 6 only it can be used, not outside that. So if I try to find out the output of this particular program, how will be the output? So p is 4, after that second line will run, then z is 8, x is 3, after that increment x. So what will be taken by x? 3. So 3 is copied to the variable y. So y, the value of y is 3, so y equals to y plus 1, it is how much? 4. So what will be the first line of output? Y inside function. So y inside function, what is the value of y now? 4. After that next line is z inside function. What is the value of z now? The value of z is your 8. After that p inside function. What is the value of p? Value of p is 4. See, z, x and p can be used wherever you want because it has a global scope. Okay, so after that the control will return to the 10th line. After that x inside the main program. What is the value of x? The value of x is 3. Then z inside the main program. What is the value of z now? 8. Then p inside the main program. What is the value of p? It is 4. Now the program will show an error while it will be running the 13th line. Why? Because so y inside the main program comma y, that means we are trying to display y, but why it will show an error? Because y is not a global variable, it is a local variable, therefore its scope is only within the lines 3 to 6. But since we are trying to use it in the line number 13, it will show as us an error. Okay, so let me run this program and show it to you. So if I run it, so see, this is the output. All the other lines up to p will come, but after that it has shown a error. See the name error, name y is not defined. Okay, so why this error is coming? Because y is not a global variable. What is y? Y is a local variable. So this is the output if I kind of zoom it to you. So the other lines will come 4, 8, 4, 3, 8 and 4 because they are the global variables. But see here y has also come because this display is within the function definition. But within the main function, since we are trying to use y, here we are getting the error as name y is not defined. Okay, so what did we learn? We learned that local variables can be used only within that particular function in which it is declared. So this is our program. So here y will be called as a local variable. Here since we are using y, local variable is used inside the main program, which is obviously not acceptable. So never try to use a local variable within the main program. So this will be your output. Okay, so if we just combine everything to revise, so this is our final thing. So here p, x, z and x, these are global variables, y is a local variable, and this will be our output. Okay, so a very important question related to this particular topic often comes in exam, which is what is the difference between a local and a global variable. I hope you are clear with the difference now. explain it with the help of a Python code. So you can give the code which I have discussed just now. Okay, so I hope that this session was useful. I'll see you again with a different topic. Hello and welcome to part 6 of the chapter working with functions. I hope you have watched the other parts of this series. If not, you can always check out. I've given the link in the description. So today's topic of discussion will be passing strings, list, tuples and dictionary. From class 11, you already know about the concept of strings, list, tuples and dictionaries. So now in this session, we will learn how to pass all these data types into functions. Okay. So a function may pass values, strings, list, tuples and dictionaries as arguments. Till now, we have passed only values into the functions. But in this session, we will learn how to pass strings, list, tuples and dictionaries. So we'll begin with strings, then list, then tuples, and finally we'll wind up with passing of dictionary. We will see one code of each data type. So let's begin with the passing of string as an argument. So let us consider one code. So this is the code. So we will learn how this code works. In this code, I have passed string as an argument. So here, so this is the code. Okay, so here, how will the program execute? The program will execute. So first line is obviously a comment. So the program will begin execution from line number 2. From line number 2, it will go to line number which? It will go to line number 4. So let's say this is the output screen. So in line number 4, what we have? Testing passing string as parameter. So if this is the output screen, what will come as the first line of output? Testing passing string as a parameter, means this particular line will be coming as the first line of output. After that, see here, what is the name of the function? The name of the function is try string. So this is what? This is the function calling. So here we have called the function try string. So within that we have passed string as the argument. What is the string we have passed? We have passed the string as welcome. How can you say that this is a string? Because it is enclosed within quotes. So this welcome will be carried and it will be copied by the variable str. So the variable is str. So what will be stored in str? In str it will be stored welcome. So from there, come to the third line. So in the third line, what we have? Print str. So what is stored in str? Welcome. So the next line of output will be welcome. So if we need to trace it, it will go something like this. First the line number 2, then line number 4, then line number 5. From line number 5, it will again go to line number 2, then line number 3. This is the tracing. Okay. So what will be the output here? This will be the output. So let's run this program and see. So this was our program. So if we run it, we'll get the output as testing passing string as parameter and the second line is welcome. Okay, so this is how we pass string as an argument. So this was our code. So what we have passed in this line, we have passed a string. After that, we have got the following output. Okay, next we'll go to passing list as an argument. So this is the code for list. Let's try to understand the code in details. So this is the code for list. So what will happen here? Here at first, what is the name of the function? The name of the function is list try. So at first, line number 1 will be executed. After that, it will come to the main part. The main part will start from line number 10. So it will come to line number 10. In line number 10, we have given a variable lst and we have assigned a list with the following values. So some values are odd and some values are even. So the aim of this program is to count the number of even numbers and number of odd numbers separately. So after that, what I have done here, I have taken two variables, one as even, other as odd, and after that here I have done the function calling list try, and within bracket I have sent the argument as lst. So the entire list, this particular list will be copied to this variable lst. So after that, we have initialized even to 0 and odd to 0. So the current value of even is 0 and odd is 0. After that, what we have for I in list. So how many values are there in this particular list? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll have indexes like 0, 1, 2, 3, 4, 5, 6, 7, 8. So 18 will be for 0, 45 will be for 1, 66 will be for 2, and so on. So for I in list. So at first the index 0, it will take index 0. What is there in index 0? It is 18. So at first the value 18 will be taken from the list. So 18 has gone. So here what will be checked? If I modulo divide 2 equals to 0, what is the value of I now? The value of I is 18. 18 modulo divide 2 equals to 0. Is it true? Yes, the remainder will be 0 if we divide 18 by 2. So it will come to the next line where even equals to even plus 1. What is the current value of even? The current value of even is 0. So 0 plus 1, the current value of even is 1. So after that, else will be skipped, and then now we are within the for loop. Then again the for loop will be executed. Now what will be taken by the for loop? This value 45. So here if 45 modulo divide 2 equals to 0, is it true or false? It is false, because if we divide 45 by 2, we will get the remainder as 1 and not 0. Therefore it will go to the else part. So what will be there? Odd equals to odd plus 1. What is the current value of odd? The current value of odd is 0. 0. So 0 plus 1 is 1. So the current value of 1 will be replaced by, the current value of odd 0 will be replaced by 1. Next, what will be taken? 66 will be taken. So here if 66 modulo divide 2 equals to 0, 66 modulo divide 2 equals to 0. So is it 0? Yes, the remainder will be 0. Therefore this part will become true. So what will be the logic? Even equals to even plus 1. What is the current value of even? The current value of even is 1. So now it will be 1 plus 1 is how much? 2. So the current value of even will be 2. So in a similar manner, the loop will run until all the values are counted. Whenever it is an even number, this part will become true. Whenever it is an odd number, it will come to the else part. And at the end, the number of even numbers and number of odd numbers will be counted. So how many even numbers are here? 1, 2, 3, 4, 5, 6. So even 6. So finally we'll get the value of even as 6. And how many odd numbers are there? So 1, 2, 3. So finally the value of odd will be 3. So how many? 1, 2, 3. So the finally the value of odd numbers will be 3. So the value of the variable odd will be 3. So our output will be, so as this loop will complete its iteration, the value of even will be 6 and value of odd will be 3. After that, what is being returned? Return even comma odd. So 6 and 3 respectively are returned, and it will be returned to which line? It will be returned to line number 11. So now what is the value stored in the variable even? 6. What is the value stored in the variable odd? 3. So in the next line, what will be shown? Number of even numbers is 6 and number of odd numbers is 3. Okay, so we'll get the output as follows. Number of even numbers 6, number of odd numbers 3. So let's run and see the output here in this case. So this is our program. So if we run it, we'll get the output as number of even numbers 6, number of odd numbers 3. So here it is not mandatory that you have to initialize the list. You can also take a dynamic input. So for taking dynamic input, what we'll do, I'll put this as a comment. The previous one I'll put as a comment. And so for taking a dynamic list, we can put this particular line. See the line number 11, lst equals to eval input enter list. So you already know that if we want to take a list as an input, we have to use the eval function. I have already discussed about eval function in the part 1 of this particular chapter. Okay, so if we run this particular program, the output will be enter list. So if I give, let's say 4, 7, 9 and let's say 32, press the enter key. So number of even numbers 2, number of odd numbers 2. So obviously the answer is correct. So we have 4 and 32 as even number, therefore the answer is 2, and 7 as and 9 as odd number, therefore again the answer is 2. So it's not mandatory that you have to initialize the list. You can also take the list dynamically. Okay, so let's see. So this was our code. Here this is the function calling. So we have taken a list as an argument and therefore we have got this as the output. Moving on, we will see how to pass a tuple as an argument. So let's take this particular code and try to understand the working of this code. So this is the code, a very small program. So at first line number 1 will be executed and then it will go to line number 4. In the line number 4, this is what? This is the function calling. The name of the function is BAZ, and what is the tuple? I think you already know that for declaring a tuple we have to enclose it within the first bracket 3, 1. That means a tuple is being passed. So this tuple will be carried by the variable my tuple. So what is stored at my tuple now? 3, 1. After that, here in the second line, so after the fourth line, the control will go back to the first line, and after that the control will go to the second line. In second line, what we have done here, we have done unpacking of tuple. We have already discussed unpacking in class 11. So in unpacking, what happens? The values inside the tuples are taken out so that it can be processed individually. So what will be the first value of? So here the first value, that is 3, will be stored in the variable first, and the second value, that is 1, will be stored in the variable second. Okay, so in first what is stored? 3. In second what is stored? 1. But here, so after the second line, which line will be executed? Third line. Here we have returned only the variable first. So what will be carried to the fourth line? The value of first. What is the value of first? 3. So the 3 will be carried to the variable x. So what will be the final value stored in x? 3. So after the third line, the fourth line will be executed, and finally the fifth line will be executed. So what will be the output? The output will be returning the first value from the tuple. And what is the value being returned here in x? The final value is 3. So you will get the output as 3. So in this way we pass tuple. So you will get this as the output, returning the first value from the tuple. Similarly, as list, here you can also go on with dynamic inputs also. So here this is our code. Let's run and see the code. So if we run, we'll get the output as returning the first value from the tuple colon 3. I hope this is clear. Next we'll go to the, so this was our code. This line is the function calling. Here we have passed a tuple as an argument, and therefore we have got the output as follows. Next, moving on, we'll come to the last data type, which is dictionary, passing dictionary as an argument. So this is our code. We'll try to understand the code here. So here, so this is our code. So here we have 8 lines. At first, line number 1 will be executed, then it will come to the main function, that is line number 7. In line number 7, see, we have defined a dictionary. All of you know dictionary has 2 parts, key is to value. We have already got it in class 11. So the first part is called key and the second part is called as the value. So this is the key, this is the key. 1001, 1002 and 1003 are the keys, and Alice, Bob and Raj, these are the values. Okay, so this dictionary has been created and it is enclosed within this particular bracket. So here, what is the name of the function? The name of the function is dict try. And what is the name of in which the dictionary is stored? The dictionary is stored by the name names. So this entire dictionary will be copied to the variable d. So now d also has this particular dictionary. After that, what is the first line? Print d. So let's, if this is the output screen, what will be printed in the first line? 1001 Alice, comma 1002 Bob, and so on. Means this particular line will be printed exactly. Okay, this will be the first line of output. After that, let's come to the second line. Second line, what will be printed? Roll separator then name. So in the second line, roll separator name, this will be printed. In the third line, what will be printed? This particular design will be printed. Then come to the next line, for k in d. So while moving through the dictionary, so that we can display it in the form of rows and columns, we can iterate in this particular manner. So what will be the value of k? Here the value of k will be the keys of the dictionary. What are the keys? 1001, 1002 and 1003. So in the first iteration, what will be taken? 1001 will be taken. So for k in d, print k. So what is the first value of k? 1001. So it will be printed here. Then what we have? We have a separator. So one separator will be there. Then comma dk. So this is the method in which we access the value of a corresponding key. So what is the name of the dictionary? The name of the dictionary is d. So dk means d1001. So what is the value stored at 1001? The value stored is Alice. So it will be printed. So what will be the line? Alice. Okay. So what will be the next value of k? The next value of k will be 1002. Therefore, when it will go to the next line, it will be printed as 1002. Then again dk. So now what is the value of k? 1002. What is stored as the value of 1002? Bob is stored. So here we'll get the answer as Bob. Similarly, next 1003 will be printed and the corresponding value for dk. Now k will be how much? 3. So Raj will be printed. Okay. After that, the control will again return back to the 8th line. Okay, because there is no return statement here. So sorry, the control will not return back to the 8th line because this is the function calling. So after this line, the program will be terminated. Okay, so the flow of control will be line number 1, line number 7, then line number 8, then again line number 1, line number 2, line number 3, then line number 4, then line number 5, then this loop will, then line number 6, then this loop will be iterated, and when all the keys are exhausted, then the final result will be printed, which is this particular output. Let's see the output properly. So this will be the output of our program. Okay, at first we have directly printed the entire dictionary. So this is the output. Then we have printed it in a systematic manner using the concept of for loop. Okay, so let's run and see this program. So this is our program. So if we run it, we'll get the output as follows. At first the entire dictionary is printed. After that, what happened? It is being printed in a tabular format. So this is how we pass a dictionary as an argument. So here in the 8th line, this is the function calling where we have passed the dictionary names, and therefore we have got this as the output. Okay, I hope passing of strings, list, tuples and dictionary through functions is clear. Okay, I'll see you again in the next session. Hello and welcome to the chapter working with functions. So this is the part 7 of this particular chapter. I hope you have watched the previous parts of this series. If not, you can always check out. The links are given in the description. So today's topic of discussion will be the different types of arguments. I have already discussed with you what are arguments, but still let's revise arguments and then we'll go to the different types of arguments. So what is an argument? The values that are passed in function call statement are referred to as arguments. So we have two things, one is function call and other is function definition. So whatever we will pass inside the brackets of function call statements, it is referred to as arguments. And what are parameters? The values that are passed in function header are referred to as parameters. So whatever will pass in the function definition header, it will be referred to as parameters, and whatever we will pass in the function call, it is referred to as arguments. So let's take this example. This is the simple example. I have discussed about this in the previous part of this particular chapter. So here, which will be an argument and which will be a parameter? See, what is the name of the function here? The name of the function is try string. So the parameter, the argument here will be welcome. Why? Because it is the function calling, and whatever we pass in function calling, it is referred to as the argument. And this is also the name of the function, but this is the function definition. So whatever we have passed in the function definition, that is str, it is referred to as the parameter. So this was simple. I discussed it in a previous part also. Now the main topic of discussion of this particular part is about the types of arguments. So let's try to understand what the different types of arguments are. So the first type of argument is positional argument. Then there is a default arguments, and finally we have keyword or named arguments. Let's discuss them one by one. We'll begin with positional arguments. So what is positional argument? When the function call statement must match the number and order of arguments as defined in the function definition, the arguments are called positional arguments. So two things you need to remember. In case of positional arguments, the number of parameters, the number of values within the function call should be equivalent to the number of values in the function definition. I'll explain it with the help of an example, and the order of the arguments should also be the same. So this is the definition. It will be very much clear when we go to the example. So let's say this is our Python code. I'll explain it in a better way in a board. So okay, so this is our code, and here we are going to discuss about what? We are going to discuss about positional argument. So as you can see, this is the function calling, this line, this 7th line, and this is the function definition. So here how many arguments do we have? We have two arguments. What are the arguments? X comma y. So in the function calling, we have two arguments. In the function definition, how many parameters do we have? We have two parameters. What are those? P and Q. So the number of arguments should be equal to the number of parameters in case of positional arguments. That's the first point. And what is the second point? The second point is that the order should also be the same. Here this is a simple program to find out the sum of two numbers using functions. We have already discussed it in the first part, in the second part itself. So here x is the first number and y is the second number. So here x will correspond to what? X will correspond to P and y will correspond to the second number, that is Q. So the number of arguments is matched. How the number is matched? Because here also we have two arguments and here we have two parameters, so the number is matched, and x is equivalent to the first number, that is P, and y is equivalent to the second number, that is Q. So the order is also matched. So this is an example of a code with positional arguments. Till now, whatever we have done, all were concerned with positional arguments only. So this is the code. Here x comma y, it is the positional argument, and why it is positional argument? Because here we have two arguments and here we have two parameters, both are matching, so the number is matching, and x corresponds to P and y corresponds to Q. So here x comma y are positional arguments since the number of arguments in function calling matches the number of arguments in the function definition. So both these should match. So if it is matching, then we can say that it is a case of positional arguments. And not only number, the order should also match. Here x corresponds to the first number, that is P, and y corresponds to the second number, that is Q. So the order is also matched. So this is all about positional arguments. Let's go to the next one, which is the default arguments. So what is a default argument? An argument having a default value in the function header is known as default argument. Okay, so default value means a fixed value. If an argument has a fixed value in the function header, then it is known as a default argument. Default values are considered if no value is provided for that parameter in the function call statement. This is very important. So default values will only be used if we do not pass any value for that parameter in the function call statement. It will be clear when we go to a code. So now let's discuss it with the help of a code. So what's the code about? So here what we have, this is a code to calculate the simple interest. So for that we have taken a function. The name of the function is interest, as you can see here. So it will receive the principal, time and rate of interest. Here we will discuss two cases. In one case we will take only the principal and take the other as the default value, and in the second case we will take all from the outside, means all we will take dynamically. So let's try to run it one by one. So here at first which line will come? Enter the principal. So I hope now you are familiar with the output. Enter the principal. So let's say we give the principal as 5,000. Okay, so this 5,000, see x has received the principal, so interest x, so that 5,000 will be carried over to p. Okay, so p is 5,000. Now see here we have not passed the values for rate and time in the function calling, but in the function definition there is a fixed value for rate which is 10% and there is a fixed value for time which is 2 years. So r and t will take the default values. Therefore it is known as default argument. So what will be the value of p? The value of p will be 5,000, r will be 10 and t will be how much? T will be nothing but 2. After that it will be calculated and the result will be returned to the variable si. After that print simple interest case 1. So whatever is the simple interest will be displayed. After that the rate will be asked. Till now we have only the principal, that is 5,000. After that the rate will be asked, which will be taken by the variable y, and after that the number of years will be asked, which will be taken by the variable z. After that let's come to the 12th line. Here we have x, y and z. What is the value of x? 5,000. What is the value of y? Let's say we take the value of y as 5. What is the number of years? You have to enter it dynamically. You can take any value. Let's say the number of years we take it as 3. So now what will happen? The value of x will be the value of p. Now whatever we will enter for rate, that is y, that rate will be replaced by this 10. So remember I have discussed one point that default values will only be taken if we do not pass any value for the default value. But here we are passing a value that is 5 as a rate for the default value, and therefore this 10 will be replaced by 5. Similarly here z is the number of years, but here number of years will not be taken as 2 but it will be taken as 3 because we have passed this as in the function calling in the form of z. Okay, and therefore finally the simple interest will be shown here. So this will be your output. So if I take the principal as 5,000, then it will take the default values for rate and time, and therefore the simple interest will be shown as 1,000. Obviously the principal is 5,000, and then what was the rate? The rate was, I have to check the rate. The rate is 10 and time is 2. So principal rate is 5 and time is 2. So PRT by 100 you will get is how much? 5 5s are 25, 25 2s are 50. Okay, I think there is some mistake here. So the rate will be taken as 10 and time will be taken as 2. So here I have taken the rate as 5. No, rate will be taken as 10. So 5 2s are 10, and here 10 into 100 it is 1,000. So in the first case the simple interest will be shown as 1,000, and after that it will take the value of rate as 5 and the number of years as 3. So this time the value of rate will not be taken as 10 but 5, and it will be replaced. The original default values will be replaced. Why the default values will be replaced? Because we have passed 5 and 3 as an argument for rate and 3. Therefore, the default values 10 and 2 respectively will be replaced. After that, the simple interest will be calculated as how much? It will be calculated as 750. Let's run and see it. So this was our code. Okay, so if I run it, let's say I'll give the principal as, you can give it as any value. So let's give it as 5,000. So I've given only the principal, but it has taken out the entire simple interest. Why? Because it has taken the default values for rate and time. So here it is for the second case, let's give the rate as 5 and the time as 3. So now the default values will be replaced, and therefore we will get the simple interest as rupees how much? We will get the simple interest as 750. I hope default arguments is clear. So here this is our code, this is our first function calling, and here the default arguments will be used. Why? Because there are three parameters here. Okay, so but here we have passed how many arguments? We have passed only one argument. Therefore, the default arguments are used in this particular case. But in the second case here, the default arguments are not used. Why the default arguments are not used? Because we have passed all the three arguments in the function calling itself. So remember, default arguments will only be used if we do not pass any value for them in the function calling. And this is our output. Now let's go to the final one, which is keyword or named arguments. So the arguments that allow us to change the order of arguments in the function call are called keyword arguments. So till now, what we have been doing, till now we have not changed the order of the arguments. We have taken the original order itself. Okay, but keyword arguments allows you to change the order also. Order means the position also. It will be clear with the help of a code. So here we can write any argument in any order. Okay, so let's say we have to calculate simple interest only. So at first, if there is principal, second there is rate, and third there is time, it does not matter. We can change the order also. We can give the principal in second also. So here we can write any argument in any order, provided we name the arguments when calling the function. So if we name the arguments, then it can be provided in any order. There is no problem about that. So let's see an example related to the keyword arguments. So here, so this is our example related to keyword arguments. Here also our aim is to calculate the simple interest only. So here this is the, here we have used it 3 times for showing you different examples. Here we have passed what? Rate and principal. See, at first what was the order? Principal, rate and time, but here we have given the rate in the very beginning and then we have given the principal. But if you want to change the order, remember to use the variable name also. You cannot just pass 3, 5,000. You have to keep r equals to 3, p equals to 5,000. Okay, and then obviously I have not given the time, so the default value of time, that is 3, will be taken into account, and therefore and finally we'll get the simple interest. In the second case, what we have done, we have passed p, r and t, all the 3, but we have given it how? We have given it in a different order. Rate we have given it first, principal second, and time first, and this is applicable. Only remember the thing is that you have to give the variable name, and along with the variable name you have to give the value if you want to use the keyword argument. So main thing about keyword argument is that it allows you to change the position of the values that we will pass inside the function calling. In the third case, let's see an interesting phenomena. Here we haven't passed any variable for 5,000. So if you do not want to pass the variable name, that is p here, then what you need to do, you should not change the position. Here I haven't changed the here I haven't mentioned the variable name, that is p, and hence what I have done, I have given it in the first position, and then the Python interpreter will not be confused. Okay, so if you do not give the variable name, then you should not change the position. But here I have interchanged the position of rate and time, but since I have interchanged, I cannot write it directly as 4,7. What will happen if I write directly? If I write directly, then 4 will be taken for rate and 7 will be taken for time, but it is not the case. So if it is not the case, then we need to explicitly mention the variable in the function calling itself. So this is about keyword argument. So hence we'll get this as the output. Let's run and see this particular program. So about keyword arguments, so this is the program that I showed in the previous slide. So here see, I am getting the interest as 450, 600 and 1400 respectively. So here what is done, here I have interchanged the position for principal and rate, and time has been taken as the default value. Here I have used all the 3 arguments, but here I have interchanged the position, all the positions. So no default value will be taken here. But in the third case, what I have done, I have not changed the position of the principal. So if I do not want to change the position, then I should not give the variable name. But since I have changed the position for rate and time, I have to give the variable names along with the values. I hope it is clear. So let's go back to the slide. So here 3 cases of keyword arguments are given one by one, and this is our output. Okay, so that's all for today. I hope this session was useful. Thank you very much. Hello students, welcome to the chapter working with functions, and this is the part 8 of this particular chapter. I hope you have watched the previous parts of this series. If not, you can always check out. I've given all the links in the description. So today's topic of discussion will be mutable and immutable properties of data objects. So from class 11 concepts, you already know what mutable and immutable is. Mutable means such data objects whose values can be changed after declaration are known as mutable, and those data objects whose values cannot be changed after declaration are known as immutable types. So examples of mutable are list, dictionaries, and examples of immutables are int, float, tuples, and some more. So here in this part, we are basically going to discuss about how a function will behave if we pass a mutable object and how a function will behave if we pass an immutable data object. So let's begin with the immutable data objects. So passing immutable data. So remember this point, if a variable is referring to an immutable type, any change in its value will also change the memory address it is referring to. So if we are passing an immutable type like integers through a functions, then if any change in value occurs within the function definition, then it will also change the memory address. And what will happen if the memory address changes? If the memory address changes, then the changes will not be reflected back to the main functions. It will be clear when we discuss it with the help of a code. So passing immutable data, let us consider this code. I'll explain this code here. So the code for understanding passing immutable type value to a function. So I've discussed a code here. So here we have 11 lines. So from lines 2 to 7, this is the function definition, and from line 8 to 11 it is the main function. So here at first what will come? N equals to 3 will come. So n equals to 3. So therefore the value stored in the variable n will be how much? It is 3. It will have a memory address. Let's say the memory address of n is, let's say, 100. Okay, after that what will be displayed? Calling function test immutable by passing n with value. So if this is the output screen, the first line of the output screen will be this one, calling function test immutable by passing n with value. And what is the value of n? The value of n is 3. After that the 10th line will run where the function calling is happening. What is the name of the function? The name of the function is test immutable, and we have sent an immutable type value through it. What is the immutable type? It is an integer. And what is the value of n? 3. So 3 will be copied to what? 3 will be copied to a. So now what will be stored in a? A will also take the value of 3. Okay, but since it is an immutable type, the memory address of a will not be 100. It will be something else. Let's say it is 200. So what will be the next line of output? Inside test immutable. So next line of output will be inside test immutable. What will be the next line? Value received in a as, so value received in a as a. What is the value stored in a? The value stored in a is 3. So we'll get the output as 3. After that, what is happening here? A equals to a plus 2. So a equals to a plus 2 means what is the value of a now? 3. 3 plus 2 is 5. So this 3 will be replaced by 5. So now a is pointing towards 5. That means the value of a now is how much? It is 5. After that, what will be what will be displayed in the next line? Value of a now changes to this line. How much? 5. After that, what will be printed? Returning from test immutable. I am writing here returning from test immutable, and after that the control will be transferred to line number 11. Why line number 11 and not 10? Because there is no return type. I have already discussed how programs can be traced in one of the parts of this particular chapter. Now after returning to line number 11, what will be printed? Back from test immutable, value of n is n. So what is the value of n? The value of n is 3. So the value of n will not be displayed as 5. The value of n will be displayed as 3, because the memory address, so this 100 is not the value, this 100 is the memory address. The memory address of n is 100, but the memory address of a is 200. What we are displaying, n or a? We are displaying n. So since we are displaying n, therefore we will get the answer as how much? We will get the answer as 3 and not 5. So what we can say, if a function is referring to an immutable data type, then whatever changes we do inside the function definition, those will not be carried to the main function. It will be carried if we use the return statement, but if we do not use the return statement, then it will not be carried to the main function. So this will be our output when we run the program. Okay, so at first the value is 3. After that, inside test immutable, these are inside the function definition, then value was 3. I have displayed it. Then we have modified the value of a to 5. Then after that, returning from test immutable, and finally when we displayed the value of n, it is displayed as how much? It is displayed as 3. Why it is displayed as 3? It is because the memory address of n and the memory address of a both are different. Okay, so let's run and see this particular program. So this is our program. So if we run it, you will get this as the output. Okay, you should execute and see this particular code by yourself in your computer. So here, so passing immutable data, this was our code. Here this n is an what? It is an integer, and it is carried, it is copied to the variable a. Since it is immutable, so the changes are not reflected back to the original function, and this is the what? This is the output. So next we will go to passing mutable data. So what happens in this case? If a variable is referring to a mutable type, then any change in the value of mutable type will not change the memory address of the variable. So in the previous case, the memory address was changing. Why? Because we have passed an immutable data type. But in this case, the memory address will not change because we have passed a mutable data type. So let's try to understand it with the help of a code. There are two cases of mutable data. This is the first case of mutable data. So this is the code. Let me explain you this code. Okay, so this is the case 1 of passing mutable type value to functions. Okay, so what is the name of the function? The name of the function is test mutable. Okay, so here what is the first line which will be executed? The first line that will be executed is this line, the line number 8. So what is there in line number 8? So what is the data type? Can you say me? This data type is a list. Why it is a list? Because we have enclosed it in this particular bracket. So let's try to understand this program. So we have created a list in the variable. What? The variable is y. So let's say this is the output screen. What will be displayed? The first line will be list before function call y. So what will be displayed here? 1, because 1 is y, in y what is stored? 1 is stored. After that, the test mutable function is being called. That means line number 10 is being called. So in line number 10, the list which is stored in the variable y, it will be copied to the variable x. But now you should remember one thing, that let's say the memory address of y is 100. So y is what? It is a mutable data type because it is a list, and the memory address of x will also be how much? The memory address of x will also be 100, because I already said that if it is referring to a mutable data type, then the memory address will not change. Okay, so what is stored in y? 1 is stored in y. So what is stored in x? 1 is stored in x, because y is copied to x without changing the memory address. So what will be the second line of output? Inside call function now. So it will be inside call function now. After that, what will be the next line? The next line will be, due to lack of space I am writing here, list received and x. So what is stored in x? You can see here 1. So the output will be 1. Next line. After that, see, x0 equals to x0 plus 1. Now what is this 0? I have already discussed in class 11 that 0, it is the index. The index starts from 0. So here we have only one element, and what will be the index of that element? So if this is the list, the index of this element is 0. So here what we are doing, x0 equals to x0 plus 2 means, what is x0? x0 means 1, because in the index 0, what is the value? The value is 1. So 1 plus 2 will get how much? 3. That means in x0, now what is stored? Now 3 is stored. That means this 1 will be replaced by 3. Why it is replaceable? It is replaceable because it is a mutable data type. Okay, so this replacement is happening in which variable? It is happening in the variable what? It is happening in the variable x. But the memory address of x and the memory address of y is same. So since both are pointing to the same memory address, therefore this y will also be changed to 3. Have you got it? After that, what will be the next line which will come in the output screen? The next line is this line, list within call function after changes x. So what will be displayed now? Is it 1 or 3? It is obviously 3, because list is a mutable type and we have changed the value from 1 to 3. In which line the value has been changed? The value has been changed in line number 6. After that, the control will come to the line number 11. So what will be displayed in the final line? In the final line, list after function call y. So since the memory address of x and y, these both are same, therefore what will be displayed here? 1 or 3? Here of course not 1, here 3 will be displayed. Okay, this is in contrast to the previous example which we discussed. There the changes were not reflected into the original function, but here the changes are reflected to the original function. Let's see the output a little bit clearly. Okay, so this is the output which we will get after running the above code. Okay, I hope it is clear. So this is the case 1 of mutable data type. Let's run and show you this particular code. So this is the code, and if we run it, we'll get the output which I have already explained to you. You should execute this code and see it for yourself. Okay, so next, so here this was our code. Here the function calling is happening and we are passing a mutable type. So here list, it is a mutable data type. So hence no change in memory address. As I have already explained, the memory address of y and x will be same in this case. So we'll get this as the output. I hope it is clear. So what can be said, concluded? Changes if any in mutable types are reflected in the caller function if its name is not assigned a different variable or data type. So here we have copied x to the variable a, but we have not assigned a to a different variable. Therefore, the changes are reflected to the caller function. That means the changes are reflected in the main function. That means we have changed from 1 to 3 and that change is reflected in the main function also. Okay, so let's go to the case 2. So what does case 2 says? See here, so this is the code for case 2. We'll discuss case 2. I'll explain it to you properly. So this is the case 2 of mutable data type itself. So let's see how this program will run. So at first, obviously, line number 10 will be executed. So here we have created a list. What is stored in the list? 1, 5. So what will be the index of 1? The index of 1 will be 0. What will be the index of 5? The index of 5 will be 1. After that, what will be the first line of output? The first line of output will be list before function call, y. So what will be displayed as the first line of output? 1, 5. Okay, I hope it is clear. It's very simple. We have created a list y and we have stored two elements in the list which are 1 and 5. So the first line we have just directly displayed y, so it will be displayed as 1, 5. After that, the function calling is happening in line number 12. So let's say the memory address of y is 100, since it is a mutable data type. So this y will be copied to x, and what will be the memory address of x? The memory address of x will also be the same as y. That means the memory address of x will be nothing but 100 itself. Okay, so after that, what will be the next line of output? The next line will be inside called function now. So only this line will be displayed. After that, here I have used /t. So I think you know the meaning of /t. /t means horizontally it will leave certain spaces. Okay, after that, what will come in the next line? List received, x. Very simple. What is stored in x? Whatever was stored in y, it is only stored in x. Therefore, what will be displayed now? 1, 5. After that, the main case 2 will start now. Please pay attention here. So in the 6th line, what we have done, we have created a new variable. The name of that variable is new itself. And there, what we have given, we have taken a list. The contents are 7, 3. So now new is a different variable, so it will not have the memory address 100. It will have the memory address, let's say a different memory address. Let's say the memory address is how much? The memory address is 200. After that, pay attention to the 7th line. The 7th line is the line which makes all the difference. Here x equals to new. That means whatever is stored in new, it will be stored in x. So what is stored in new? 7, 3. Now, so what will be stored in x? In x also, now 1, 5 will not be stored. Now, since new has been assigned to x, therefore, now in x also, instead of 1, 5 as previously, now what will be stored in x? 7, 3 will be stored in x. Also, the now x will not point to the memory location 100. Okay, now the memory address of x will also change to the memory address of new. What was the memory address of new? It was 200, 100. These are just fictional values. Okay, this is not the accurate memory address. I have just taken a fictional value. You need not remember these memory addresses also. So now what will be the memory address of x? The memory address of x will not be 100. Rather, the memory address of x will now change to how much? 200, because we have assigned it a different variable which is new. After that, what we have done, x.append 8. In class 11, you already got about the append function. What append function does? with the help of append function, we can add certain more elements to the already existing list. The new elements will be added to the end of the list. So what is the current content of the list stored in X? It is 7, 3 after modification, after the 7th line. So now 8 has been appended. So the final list of X will not be 7, 3, it will be 7, 3, 8. So what will be the next line of output? Here slash t has been used, so it will be it will leave some horizontal space, and what will be displayed here? List within called function after changes x. So what will be displayed? 7, 3, 8. It will be displayed in the output screen. After that, see, the control will come back to the 13th line. Here what will be displayed? List after function call y. See, the memory address of y was 100, but the memory address of x has been changed to 200. So what will be displayed here? 7, 3, 8 or 1, 5? Of course, 1, 5 will be displayed. Okay, so you may ask that it is a mutable data type, so why the changes are not reflected? The changes are not reflected because even though it is a mutable data type, we have assigned it to a different variable in the middle of the function. So this is the case 2. So if a mutable data type is assigned a different variable, then the changes are not reflected back to the calling function. So why the changes are not reflected back to the calling functions? It is so because the memory address itself changes. Okay, so if we see the output, so this will be the final output. Okay, I hope you have understood the output. Let's run and see this particular program. Okay, so this is our program of case 2. So this is our output. See here, this line, list within call function after changes, this line is within the function definition itself, but since the memory address has been changed because of assignment of a new variable, therefore the changes are not reflected back to the calling function. Okay, I hope it is clear. Now let's go back to the slide. Okay, so here we have passed immutable type. Okay, so but here the main change has happened in the 7th line, but list is a mutable type, but it is assigned a different variable, hence the changes are not reflected back to the calling function, as I have already explained in the last few minutes. Okay, and this is the output. So what can be concluded? We can conclude that changes, if any, in mutable types are not reflected in caller function if its name is assigned a different variable or data type. So if we assign its name a different variable or data type, then the changes are not reflected back to the main function. Okay, I hope these concepts are clear. I'll see you again. Thank you very much.